Okay, today we're going to be covering function composition. Function composition, right below is the definition here. If we have f and g be functions of x, the composition of f with g is denoted f open dot g, and it's defined as f of g of x. Basically, what it says is we're going to take the g of x equation and plug it into the f of x equation. The domain of y equals f of g of x is the set of domain values of g whose range values are in the domain of f. The function f open dot g is called the composite function of f with g. Those are all the definitions. As far as Algebra 2 goes, this part isn't a huge deal about the domain, but it basically means if an x value of g of x gives a y value that is not in f of x's domain, then that's not part of the composite function. But looking at examples of what a composite function looks like, this is an example of a linear function right here, g of x. This is the square root function, the parent function for square roots. The composite function would be f of g of x is equal to the square root of 2x plus 1. That is a simple example of a composite function. Now we're going to do some composite functions here. So for the first one, example 1, let f of x equals x squared minus 1 and g of x equals 2x plus 1. We're supposed to find f of g and g of f. So I'm going to split the slide here into two sections. I'm going to first find f of g, then I'm going to find g of f. So when I do this, for f of g, that means f of g of x. So what I tell my students to do is to go through the outside equation, in this case, the f of x equation, and anywhere you see an x, put parentheses. So I see it's x squared minus 1, so I'm going to put parentheses squared minus 1. Now, what goes inside the parentheses? Well, g of x goes inside the parentheses, so 2x plus 1. And you can see I'm using different colors. It does help make things go a little bit clearer on this particular topic. So I like to use the different colors whenever I first start it. But now I'm going to go through order of operations just to simplify. I'm going to zoom in so it's a little clearer. So here is the initial setup for f of g. Now I'll just go through and simplify. So I'm going to deal with the exponent first. To deal with the exponent, I have to write the 2x plus 1 twice. And I'll distribute it all out. Give me 4x squared plus 2x plus 2x plus 1. The minus 1 we need to make sure we bring down. To finish it off, I'm just going to combine any like terms. So I got 4x squared is all alone. Got 2x and 2x is going to make 4x. And then the positive one and the negative one, they are going to cancel out. So f of g is equal to 4x squared plus 4x. Now I'm going to move over and go to g of f. Now these are not the same thing. They're very, very similar, but they're not exactly the same thing. For g of f, that will mean g of f of x. So whenever I go to initially set it, again, I'm going to go through the outside function and replace x with parentheses. So the outside function is 2x plus 1. So 2 parentheses plus 1. Inside the parentheses goes f of x, which is x squared minus 1. So this is the initial setup for g of f. Now, once again, I'll go through order of operations to simplify. I don't have any exponents on the outside of the parentheses, so I'm just going to go straight to the multiplication. I'll distribute through, giving me 2x squared minus 2. My plus 1 needs to come down. Lastly, I'll combine like terms. So 2x squared will stay the same. Negative 2 plus 1 is negative 1. So overall, g of f is 2x squared minus 1. So notice, even though these two compositions are using the same two functions, depending on which one you plug into the other, can change the answer. They're not the same answer. Okay, so example 2, we're doing another composite function. But if you look, it's f of g of 3. Just like yesterday in function operations, the 3 at the end here does not mean to multiply things by 3. Instead, it means to plug a 3 in. So there's two main ways you can do this. I'm going to show both ways in the video, but I probably will only do one way in the class. So method 1 and method 2. Use whichever method you like. I don't really care. It doesn't make a difference. You should still get the same result as long as you do it correctly. So, for method 1, we're going to use basically what we did on the previous slide. I'm going to find f of g of x. I'm going to find that first. So if I do that, if we still have the same two functions as we did earlier on. So we said f of g of x earlier was 4x squared. What was it? Plus 4x. So that was f of g of x, which means if we want to find f of g of 3, which is what f open dot g, the composition of f with g of 3 means, from here, I will just plug in the 3. So 4 times 3 squared plus 4 times 3. Go through, we got 9, and 9 times 4 is 36. Plus 12 is 48. So that was the first method. The first method is great if you already know what f of g of x is. The second method I prefer if I don't already have to find f of g of x. So the way I do it for the other method is I start by writing f. I'm going to switch to the other color since I've been using red for f of x real quick. So f of g of 3. I'm just going to find this outright. So when I do this with the second method, without knowing f of g of x in the beginning, what I do is I start with the inside. I first go through and find g of 3. So I'll plug 3 into the g of x equation. So 2 times 3 plus 1. I'm going to kind of keep my f of x on the outside. I haven't actually used it at all. Well, what is 2 times 3 plus 1? That gives me 6, plus the 1 is 7. So what I'm actually looking for is f of 7. In f of 7, if I plug that in, parentheses squared minus 1, plugging 7 in. 7 squared is 49, minus 1 is 48. Either way, you get the same answer. I prefer the second method if I don't already know what f of g of x is. But either way, you still get the same answer. And both methods are about the same amount of work. Okay, example 3 here. So in example 3, we have the functions f of x and g of x graphed below. We're supposed to find the value of f of g of 2. And then we're going to sketch the composition. We're going to use Desmos to help us with that. So in order to actually do this, I'm going to first go through and find f of g of 2 by hand. And to do that, you just simply look at what f of g of 2 means. So f of g of 2 means f of g of 2. So I'm going to ask myself, what does g of 2 mean? Well, g of 2 means what's the y value for the g of x equation when x is 2. So here is x value of 2 on the g of x equation. The y value here, well, the y value here is 0 because at 2 it's an x-intercept. Therefore, g of 2 is 0. I haven't done anything with f of x or f of yet, so it's going to come down. Now I'm going to take that result, the 0, I'm going to look at f of 0. So I'm going to go over to the f of x graph. I'm going to look for the x value of 0. Here's the x value of 0. What's the y value here? And go and find my graph. The y value here is -1. So f of 0 is -1, which means f of g of 2 is -1. So that is how we do it by hand. Now I'm going to pull up Desmos here, and we're going to use Desmos to help us. Okay, here I've graphed both f and g. The f of x equation that we were looking at earlier is x squared minus 1, and the g of x equation that we were looking at just a second ago is x minus 2. So you can see that the red one is graphed here, the blue one is g of x graphed there. For the composition, we're going to look at the composition. So I'm going to go into my graph, and I'm just going to simply type f of g of x. So f of g of x is this green line. I'm going to cover up my other two lines just so we can focus on the green line. So here is f of g of x. So we can sketch that on our graph here. I'm not actually going to go and sketch it, but you can see some key points for this graph are the fact that the x-intercepts are 1 and 3, and it has a minimum of -1 at the x value of 2. So you can get that nice parabola shape drawn in using those 3 points. Our question does also ask us to find the value right above the window here. Find the value of f of g of 2 with Desmos. So if I look at that, I can do it one of two ways. I can literally go in here and type in 2 instead of x, and it will tell me right away that the answer is -1. Or I can do it this way and use the graph, which I like to do myself. Just by looking at the graph, I can see that here is 2. Again, the green line is representing f of g of 2. Well, what's the y value for f of g of 2? If I look down, the y value is -1. No matter which way, we should still get the same answer of -1.